Hello students, welcome to Narayan PU College online classes. So in the last class, we have discussed about the chemical properties of the noble gases. So in that one, and first noble gas or noble compound was prepared by Niall Bartlett in 1962. So after that I mentioned so many compounds of xenon and krypton have been prepared. Clear? So now we will discuss here xenon compounds. Clear? This means xenon and krypton, mainly xenon. Xenon mainly it forms the compounds with highly electronegative atoms like oxygen and fluorine. Clear? Why? Because to involve in the reaction it has to lose the electron. To lose the electron, here we have to put the very highly electronegative elements. Then only highly electronegative elements will try to pull the electrons from the xenon. So that's why, and we have to, and means most of the xenon compounds are oxides and the fluorides. Clear? So first we will discuss here xenon fluorides. Put the heading here, xenon fluorides. Xenon fluorides. Clear? So you know that here xenon fluoride mainly xenon forms three types of fluorides. One is xenon difluoride XeF2, and the second one is xenon tetrafluoride, and the third one is xenon hexafluoride. Clear? So these are the main three compounds of the xenon fluoride. So now first we will discuss what are the preparations, clear, and the properties one by one we will discuss. Clear? So preparation, how we will prepare these compounds. Clear? So these compounds are prepared directly by the combination of xenon and fluorine. Clear? Take here xenon and plus fluorine. Clear? Xenon plus fluorine, and maintain here 673 Kelvin. Clear? 673 Kelvin and 1 bar pressure. Clear? And take here excess amount of xenon. Which amount we have to take here? Excess amount of xenon. Clear? Then what the compound you will get here? You will get the compound. If you take excess xenon, then you will get the compound is XeF2. Clear? So why I have mentioned here excess? If you take excess of fluorine, and it may form the xenon tetrafluoride and xenon hexafluoride. Fluorine excess means you may get these two compounds also along with this. So that's why you have to take the excess amount of the xenon, you will get the xenon difluoride. Clear? And the next one, and xenon and plus F2. Clear? And you will get, take here 873 Kelvin and 7 bar pressure. Maintain 7 bar pressure. But here take, this is 1:5 ratio. How much ratio you have to take here? 1:5 ratio. If you take 1 mole xenon and 5 mole, you have to take the what it is fluoride, like that. 1:5 ratio. Then you will get the compound is XeF4. So you have to take how many moles here? 2 moles. This is xenon, which fluoride? Tetrafluoride. And the next one is, when is xenon is treated with the fluorine, this is 1:20 ratio. Take the excess amount of fluorine, then what you will get from here? Take here 473 Kelvin and here 60 to 70 bar pressure. Maintain high pressure here. Then what the compound you will get from here? Xe, F6, and how many moles you have to take? 3 moles. So this is about the what it is one here, 573. Take here 573 Kelvin, 573, 673, 873. Clear? So what it is here? This is the preparation of what it is, and also xenon hexafluoride. Xenon hexafluoride can also be prepared from the xenon tetrafluoride. Clear? So how means, take here XeF4 and take here dioxygen difluoride. Clear? So I already mentioned here fluorine forms two types of oxides, mainly OF2 and OPF2. OF2 and what it is here? OPF2. Both are I mentioned very powerful fluorinating agents and also oxidizing agents. So that's why what is the fluorinating agent? What it will do? It provides the fluorine to HCl4. How many fluorines are there? 2. So that's why you will get here FeX6 plus what you will get here? Oxygen. So these are what it is here preparations of what it is and xenon products. So next one is here properties of what it is here properties of xenon fluorides. Properties of which one here? Xenon fluorides. Clear? So these all are these xenon fluorides. How many fluorides we have? 3 fluorides. All xenon fluorides are crystalline solids. All are which one here? Crystalline solids, and they easily sublimize at the room temperature. They easily sublimize at what is room temperature. If you want, you can put here physical properties. Clear? So first physical properties, then chemical properties we will discuss. Clear? So physical properties we have only 2. Clear? Physical properties. Physical properties of which one? Xenon fluoride. Yeah. So physical properties. What it is here? All xenon fluorides are crystalline solids. Clear? Like here. All xenon fluorides. All xenon fluorides are what it is here? Crystalline solids. Crystalline solids. They all are crystalline solids. Clear? And they easily sublimize. You know, sublimize means what? And from the solid state to they can easily evaporate into gaseous state. Clear? Easily converted into gaseous state. So that's why all are sublimize. All are sublimize at room temperature. Room temperature means how much? 298. Okay. So these are the what is physical properties. Clear? And the next one here put the heading chemical properties. What is here? Chemical properties. So chemical properties, and the first one is they readily react with the hydrogen. Clear? With the hydrogen, all the difluoride, tetrafluoride, and hexafluoride react immediately. Clear? So what it is here? If I take here HCl2 plus what it is hydrogen, then what you will get here? It combines with the hydrogen and will give, and what you will get here? 2HF. Clear? And in the same way, HCl4, when it is treated with the 2 moles of hydrogen, you will get xenon and 4HF. Clear? In the same way, xenon hexafluoride treated with 3 moles of hydrogen and gives xenon and what is here? 6HF. So this is about the what is here? Reaction with hydrogen. You can put heading if you want. Reaction with what is here? Hydrogen. Yes? So next one. And second property here is they act as powerful oxidizing agents. Clear? No? So second property what is here? Oxidizing agent. Clear? No? So oxidizing properties. You can write oxidizing agent or oxidizing property. Clear? So they act as oxidizing agents. Clear? So oxidizing agents means what it will do, and it will oxidize mainly. It will oxidize HCl to what it is here? Chlorine. Any oxidizing agent, it oxidizes HCl to what it is? Chlorine. So here also, if I take suppose HCF2 plus reacted with HCl, reacted with what it is here? HCl. Take here 2 moles and 2H, because this chlorine and hydrogen will combine, and first of all xenon will come, because these two will combine, you will get the 2HF plus here what is left here? Chlorine. So chlorine. This is clear. So xenon difluoride oxidizes HCl into chlorine. Clear? It also means these compounds can also oxidize. Clear? Potassium iodide into iodine also. Potassium iodide into what is iodine. Simple. You can see here. And if I take suppose previous I have taken HCF2, then I will take here HCF4 and plus what it is here Ki. Then what the compound you will get, you see, and here potassium and fluorine and will be removed as a potassium fluoride. So how many moles I have to take here? 4 moles, and Xenon will form here, Xenon plus and 4 Kf plus what we will get here? 2 moles of iodine. Clear? So this is about what it is here, oxidizing property. First we have written here reaction with hydrogen. The first one what it is here, reaction with hydrogen. Clear? So you can put here a reaction with hydrogen. First one is reaction with hydrogen, and second one is what it is here, oxidizing agent. Clear? Oxidizing agent. And next we will discuss fluorinating agent. So now we have discussed about reaction with hydrogen and oxidizing agent. And the third one is they act also xenon fluorides. Xenon fluorides means difluoride, tetrafluoride and hexafluoride can also act as fluorinating agents. Fluorinating agents. They act as a which one here? Fluorinating agents. So you know that here fluorinating agent means what it will do. Oxidizing agent means it provides the which one? Oxygen. Fluorinating agent means it provides the which one? Fluorines. Clear? So that is means if you take here XeF4 and treated this one with SF4. Treated with the what is my SF4. It acts as a fluorinating agent, so it provides the fluorines to which one? SF4. Then it will be converted into Xe plus SF6. Clear? So if you balance this, clear, and take the here 2 moles because here 8 fluorine atoms are there, but fluorine can form maximum what is SF6. So that's why take 2 moles here and take 2 moles here. Clear? Why? Because you know 2 into 4, 8, 8 plus 4, 12, and 2 into what it is here 6, and you will get the 12. Clear? In the same way, you can treat this one XeF4 and treat it with the platinum. Then what you will get from here? You will get the Xe plus what it is platinum. You know tetrafluoride. What you will get from here? Platinum tetrafluoride. Means it is providing fluorine atoms to other compounds. Means what it is here platinum is there and here SiF4 is there. So it now in this case it is act as a which one? Fluorinating agent. In the same way, if I take here XeF2 plus NO nitric oxide, what is known here? Nitric oxide NO. Clear? So then what you will get here? It provides 2 fluorine atoms here. So here you will get Xe plus what is here? 2 NOF nitrosyl fluoride. What we will call this is nitrosyl fluoride. Nitrosyl what it is here? Fluoride. So this is about what it is here? Fluorinating agent. Clear? And the next important one is here. Next one is hydrolysis. Clear? So what is the next one here? Fourth one is hydrolysis. Clear? So hydrolysis. Fourth one is hydrolysis. Clear? So here and xenon difluoride, tetrafluoride and hexafluorides, they are readily soluble in water, means they react easily with the water. Clear? And it depends upon that and different compounds, so that's why they react with the water in different way and gives the different types of products in each cases. Clear? So first one, if I take here XeF2, clear? XeF2 and just hydrolysis this compound. Clear? So what the compound you will get here? Xenon and HF and oxygen. Clear? So means what we have to take here, you see, and I will write first of all. Xenon you will get here plus what you will get 2 HF you will get and plus what you will get oxygen. Clear? So shall I write in this way? Clear? So what you will get, you see, Xenon plus HF plus oxygen. This is the reaction. Clear? So you know that here oxygens how many are there? 2 are there, but here 1 is there. Multiply this one with the 2. When I multiply with the 2, hydrogens 4 are there, here 1, only 1 is there. Multiply this one with the 4. Then how many fluorine atoms are there? 4. So that's why here I have to multiply with the 2. Then 4 fluorine atoms. And here xenon is 2 and here 1. So multiply this one with the 2. So when xenon difluoride react with the water, what are the compounds? We will get xenon and here HF and what we will get? Oxygen. Clear my here? In the same way, and if you take xenon, tetrafluoride, when reacted with the water, and this reaction is very important, it is a disproportionation reaction. Xenon tetrafluoride reaction with water is which type of reaction? Disproportionation reaction. Clear? So why means, you see what the products you will get here. I will write products down. Clear? Xenon and XeO3 and same HF plus what it is, oxygen. Clear? You see that in this case, and all compounds are same, but extra one is coming. Have you observed here? If you compare with the xenon, tetra means difluoride. Xenon is there, xenon, and HF is there, HF, and oxygen is there, oxygen. And to balance this, we have already discussed it so many times. Oxidation number method. If you balance this, and you will get the 6 here, and you will get the 12 here. Clear? So then, and if you balance these compounds, clear? So you will get here 3 oxygens, clear? And 24 HF, because here you get 24 HF, clear? And here 2 and here 4. That balance, you balance that one using the what method here? Ion means oxidation number method. We have discussed it so many times. Again, I will not discuss here. You can try it. Clear? Otherwise, simply just remember now, balancing equation not required. What required is which products you are getting in this reaction. That is the important. Clear? So that's why you see here Xe and here XeO3 HF. In this case, you see xenon. What is the oxidation state here? +4. Because fluorine is -1 and -4 means it is a +4. Here it is which one? 0. And what is the oxidation state here? -2. 3 into -6 means here what is the oxidation state? +6. Clear? Means the same element undergoing both the oxidation and what it is not here? Reduction. In this case, you see xenon +4 to xenon 0. Which reaction it is? Reduction. It undergoing what it is? Reduction. And +4 to +6, it is a which reaction? It is an oxidation. So that's why the same element undergoing both the oxidation and the reduction, and those type of reactions we will call as a disproportionation reaction. So this reaction is a disproportionation reaction. Disproportionation. This reaction we will consider it as a disproportionation reaction. Clear? Why? Because I already mentioned. Clear? And in the same way, if I take here, this is difluoride and this is tetrafluoride, and the third one is what it is? Third one is hexafluoride. Clear? What is there here? Hexafluoride. Whenever hexafluoride reacts with water, and here in this case, and whether it is completely hydrolysis or partially hydrolysis, we have to identify. Clear? So first of all, suppose it is partially hydrolysis, then what the compound you will get? Partial hydrolysis means what the compound you will get? H2 is there, and here F2. Then what you will get? HF will be removed, and oxygen is left here. XeO4 you will get. Xe, one oxygen left, and F4, and you will get what it is? 2 HF. Clear? So this is partially hydrolysis. Clear? And another one, if you take here XeF6, take 2 moles of water, then what it is? Xenon oxy tetrafluoride. Clear? Xenon oxy tetrafluoride. Clear? So if I take here 2 moles, I will write in here. In this, I will write. If I write, you see in this one, the first one, xenon hexafluoride, partial hydrolysis. Clear? Then what you will get here? 2 hydrogen and 2 fluorine atoms will be removed as a HF, 2 HF, and what is left? Xe left, oxygen is left, and 4 fluorine atoms are left. So xenon OF4 plus what you will get, 2H. Clear? What we will call here? Xenon oxy tetrafluoride. Clear, ma? So xenon oxy tetrafluoride. Xenon oxy tetrafluoride. Clear, right? So next one is, when it is reacted with 2 moles of water molecule. 2 moles of water molecule. What we will get, you see? And if you take here 2 molecules, 4 HF, 4 hydrogens and 4 fluorine atoms will be removed as a 4 HF here. Remember, what is left here? 2 oxygens are left and 2 fluorine atoms are left. So XeO2 and F2. This is one of the important reactions for the PU examination. So what they will give, this reaction they will give, and they will give here 2 HF, then they will put here dash, you have to fill that one. Easy. You see what is left, because you see, first of all, less electronegative atom you have to write, least electronegative atom, and less electronegative atom and highly electronegative atom. Fluorine is highly electronegative atom, you have to write at last. You should not write XeF2O2. Clear, my dear? So that is the thing. So now central atom always should be, central atom should be, means less electronegative it should be. Clear? So that's why. So in this case, and here it is XeF6 when reacted with this is H2O. Then what you will get, 3 fluorine and 6 fluorines and 6 hydrogens will be removed as a 6HF. Then you will get XeO3, xenon trioxide. What it is, here? Xenon trioxide. Xenon, what is it? It is complete hydrolysis. Same, all fluorine atoms are removed. So this we will call, what it is, here? Complete hydrolysis. This is complete hydrolysis. Clear, no? So this is complete hydrolysis. These two are what it is, partial hydrolysis. Partial hydrolysis of what it is, XeF6. Then you will get what it is, xenon oxy tetrafluoride, xenon dioxy difluoride. What is the name? This is xenon dioxy difluoride. Dioxy difluoride. So this is about the, what is known here, reaction with the water. Clear? So here very important, when this hydrolysis is important, they are asking in the PU examination. If you take difluoride, you will get only xenon, HF and O2. And if you take xenon tetrafluoride, it gives the xenon and xenon trioxide and HF and O2. Extra what is coming here? XeO3. And finally, if you take XeF6 complete hydrolysis, you will get the xenon trioxide plus what it is here? HF. Clear? So this is about one chemical reaction is there, that will be discussed. So next one is, when these xenon fluorides reacted with and fluorine acceptor species and fluorine donor species, how they will react. Clear? So simple, I will write one example here, another one reaction, and whenever xenon fluorides reacted with fluorine acceptors, if I take here SF5, what I have taken here? SF5. SF5 means what it is? Sulfur, penta, it is phosphorus, not sulfur. Sulfur it forms, 5. So here what it is? Phosphorus, pentafluoride. So what the compound you will get? You see here in this case, it is a PF5 is a fluoride acceptor. It is what it is here? Fluoride acceptor. Why? Because if you means it is phosphorus it is having, it can form maximum how many bonds? 5 bonds, but it can also extend its valency to the 6 because they have empty d orbital. If anyone is giving electrons to phosphorus, it can form a bond. So that's why it is a fluoride acceptor. So it will provide the fluorine. Then what happens, you see, and you will get XeF plus, because it is losing one fluorine, positive, and it is gaining one fluorine, PF6 and minus. Clear? You are getting, in this case you are getting cationic species. Xenon is in which form? Cationic form. So it is what it is known here, cationic species. You are getting which one? Cationic species. Whenever xenon fluorides reacted with the fluorine acceptor and gives the what it is known here, cationic species. Clear? In the same way, if I take here XeF4 and SbF5, same here also. This is what is known. And nitrogen, phosphorus, arsenic, antimony, same group only. Here also it can form. It has the d orbital. So when it gives, then what it is known? XeF3 plus. Then what it is known? SbF6 minus. So here. And xenon compound is in which form? Cationic form. So that's why it forms which one? Cationic species. In the same way, and it is with the fluoride acceptor. If we take with the fluoride donor, with the fluoride donor. Clear? So I will take here XeF6 plus MF. M means it is a metal. These are metal fluoride. Metal means sodium. You can take potassium, rubidium, cesium. M is equal to what it is known here? Sodium, potassium, rubidium, cesium, etc. Clear? So then, what will happen? You see. Then what it gives here? It is a fluoride donor. It is a what it is known here? Fluoride donor. Previous is what it is? It is a fluoride acceptor. Now it is a fluoride donor. Then what you will get here? Xe, and M plus. It is losing its fluorine, so that's why positives are. It is gaining fluorine, so that's why F7 minus. Now it is a which species here? Xenon compound is in anionic species. Clear? That is, whenever xenon fluorides react with the fluoride acceptor and forms the cationic species, whenever xenon fluorides reacted with the fluoride donor and it forms the anionic species. Clear? So this is about what is the reaction with the fluoride acceptor and fluoride donor. And the next one here we will discuss. Okay. So next one is xenon oxides. Okay. Mainly xenon forms two types of oxides. One is xenon trioxide and another one is xenon tetroxides. Clear? One is xenon trioxide and another one is xenon tetroxide. So just I will this is not that much required in the answer textbook. They have given only the structures of these molecules. Yeah. So just I will say the preparations here. So what is the preparation and how we will prepare the XeO3? Just now only I have mentioned here. Take the XeF6 and complete hydrolysis you do. Then what the compound you will get? And XeO3 and plus what it is known here? You will get the and 6HF. This is the one preparation. Yeah. And but if you take here, how we will prepare the XeF4 means we will take the barium perxenate. What it is known here? Barium perxenate. Be2Xe, perxenate means what it is known? O6. This is treated with the H2SO4. It is treated with the what it is known here? H2SO4. Then you will get the compound is. Clear? So what you will get here? XeF4 and barium and sulfate means you have to take 2 moles here and 2 moles of barium sulfate. Clear? So then what will be there here? Hydrogen is there. Hydrogen will be removed as a H2. So this is about the preparation of what is known here. 2 4 hydrogens are there and here. Clear? So this is about the preparation of xenon trioxide and xenon tetroxide. Barium perxenate. This is barium perxenate. Whenever treated with the H2SO4, you will get the XeO4. And very important here, XeO3 is, it is a colorless explosive solid. It is a very explosive. Clear? It is a what it is known here. XeO3 is colorless solid, and it is highly explosive. Clear? So this is XeO3 is highly explosive. Explosive. Okay? And if you take here XeO4, it is not that much stable of XeO3. Clear? It is a unstable, so easily it is decomposed, and easily it decomposes and it gives the Xe plus and 2. This is easily unstable. This is what it is here, unstable, and it easily decomposes into xenon and what it is here, oxygen. So these are about the what is compounds of xenon, xenon fluorides and xenon oxides. We have fluorides mainly 3 fluorides: difluoride, tetrafluoride, hexafluoride, and it forms here, you know, and XeO3 and XeO4. Oxides are trioxides and xenon trioxide and xenon tetroxide. 2 types of oxide. So here next concept. This is important for the PU examination also. So structures of xenon compounds. Clear? So the first one here, xenon difluoride. Clear? So xenon difluoride. What is the structure of this compound? Clear? You see now. And xenon is forming how many bonds here? 2 bonds. Means how many bond pairs it will be? Total how many bond pairs it will be? 2 bond pairs. Just xenon, just assume. And xenon is forming here how many bonds? 2 bonds. 2 bonds means how many bond pairs here? 2 bond pairs. Clear? Means xenon has totally how many electrons outer configuration here? Total 8 because NS2, NP6, and NS2, NP6 means total 8 electrons. In the 8 electrons, 2 electrons are used to make it 2 bonds. So how many electrons left here? 6 electrons. 6 electrons means they are in form of which one? Pairs. Clear? How many lone pairs will be there here? 3 lone pairs. Otherwise, simply you know that here xenon. What is the electronic configuration? Electronic configuration here is NS2, NP6. Clear? Here there will be empty d orbital for the xenon. Clear? Empty d orbital. So now it is forming how many bonds here? 2 bonds. If it wants to form 2 bonds, and xenon should have how many unpaired electrons? 2 unpaired electrons. So means, and the first excited state, one of these electron will move in the d orbital. So how many unpaired electrons are there? 2 unpaired electrons. These 2 unpaired electrons will form the 2 bonds with the 2 fluorine atoms. Then these how many lone pairs are present here? 3 lone pairs. That is. If you take xenon difluoride, and for this compound we have 2 bond pairs, and how many lone pairs here? 3 lone pairs. Clear? And I already said, whenever lone pairs are greater than bond pairs, the shape of the molecule is linear. Clear? So it is a which shape here? The shape of molecule is what it is here? Linear shape. So what is the shape here? If I write here xenon and here fluorine and fluorine, this is a linear. So how many lone pair atoms? How many lone pairs are there? There are 3 lone pairs. So this is linear. This is what it is here? XeF2. Okay? In the same way, second one. Second one is here XeF4. What is the second one here? XeF4. Clear? So if I take here XeF4, clear? So now first of all, bond pairs and lone pairs. How many bonds it is forming? 4 bonds. 4 bonds it is forming means it should have 4 unpaired electrons. Unpaired electrons only participate in the bond formation. Second excited state, one of these electrons will move here. So one of these electrons, how many bonds are unpaired electrons are there? 4. So that's why it is forming how many bonds here? 4 bonds with the 4 fluorine atoms. So how many bond pairs are there here? There are 4 bond pairs. And second, how many lone pairs are there? There are 2 lone pairs. Clear? One by one, and very important, I forgot here to write hybridization. What is the hybridization here? 2 plus 3, 5. 5 means what is the hybridization? sp3d, and 3 plus 1, 4, 4 plus 1, 5. This is hybridization is sp3d hybridization for this compound. Clear? In the same way, how many here? And total 4 bond pairs and 2 lone pairs. And total how many one here? 6. 6 means what is the hybridization? sp3. D2 is the hybridization. Whenever there are 4 bond pairs and 2 lone pairs, what is the shape of the molecule? The shape of the molecule is clear? Square planar. What it is here? Square planar. Clear? See what is the structure. Here xenon and it is central square planar. Clear? So here xenon, and here what is there? There are 4 fluorine atoms here, fluorine, fluorine and fluorine. There are 2 lone pairs here. This is lone pair. Clear? So then what the compound you will get here? You will get the compound is what it is here? HCl4 square planar. And third one. What is the third one here? Third one is HCl6. HCl6. Clear? How many bonds it is forming? 6 bonds means it is next excited state, third excited state. So here 6 bonds are there. So that's how many bond pairs it has. And the 6 bond pairs. And how many lone pairs it is having? There is only one lone pair. So that's why one lone pair. Clear? So then what is the hybridization? 6 plus 1, 7. 7 means what you have to write? sp3 d3. Why? Because here 3 plus 3 6, 6 plus 1 7. So totally what it is here? sp3 d3. So then what is the shape of this molecule? The shape of the molecule is distorted octahedral. What is the shape of the molecule here? Distorted octahedral. What is the means distorted octahedral means? This is clear. So if you take here in the central atom, and this is fluorine and fluorine, and here this is, if you take in this way, this is exactly octahedral. If you do like this, then it is exactly octahedral. But distorted octahedral means, you see here 6 bonds are there. There is a one lone pair. Lone pair also has to be introduced in this structure. So that's why one of the lone pair will come here. Whenever one of the lone pair will come, and bond pair and lone pair repulsions will be there. So this bond, and it is just distorted. That is. So that structure we will call as what it is distorted octahedral. So how many fluorine atoms are there? Fluorine, fluorine, and here fluorine. So totally 6 fluorine atoms are there, and this is. So this is about the what it is here, and shape and structures hybridization of the what it is xenon tri and xenon difluoride, tetrafluoride, and hexafluoride. So next one is we have to discuss about the structure of oxides now. And xenon trioxide. I already mentioned xenon forms how many oxides here? 2 types of oxides. One is xenon trioxide and another one is xenon tetroxide. So first of all we will discuss about the structure of xenon trioxide. Clear? So you know that here in this one compound, xenon is reacted with the oxygen, means xenon having how many oxygen atoms here? 3 oxygen atoms. You know that. And 3 oxygen atoms are there. Each oxygen will make 2 bonds with the xenon. Oxygen forms how many bonds? 2 bonds. Clear? So that's why if I write the structure of this molecule, and here simple, I don't know what is the structure, but you know this is the double bond. Because and oxygen always form how many bonds here? 2 bonds. So 3 oxygens are there. It will form how many bonds here? 6 bonds. Clear? Means just now I mentioned here xenon electronic configuration. So what is this one? NS2 means NP6 common electronic configuration I am saying. So here next one which orbital will come? And empty d orbital. Clear? So xenon is forming how many bonds with the oxygen? And 6 bonds. 6 bonds means it should have how many unpaired electrons? It should have 6 unpaired electrons to form a 6 bonds. So that's why. And in the first excited state, one of these electron will come here. And second excited state, another electron will come here. And third excited state, and this is electron. So total how many unpaired electrons are there with the xenon now? And 6 unpaired electrons. When it is having 6 unpaired electrons, it will form, xenon will form how many bonds here? Totally 6 bonds here. Clear? So that's why whenever xenon is making bonds with the oxygen, and it will have the 6 bond pairs. What it is here? 6 bond pairs. Can I write 6 bond pairs? No. Why? Because you know that this is the sigma bonds and this is what it is, pi bonds. But we will never consider pi bonds in the hybridization. Clear? So that's why. How many bond pairs we have? We have 3 bond pairs. And how many lone pairs we have? You see here, there is one lone pair. All are here, they involved in the bond formation. But one is sigma bond and another one is the pi bond. So that's why we have 3 bond pairs. Sigma bonds only we will consider as a bond pairs, and there is a one lone pair. So total how much more here? 4. 4 means what is the hybridization? The hybridization is sp3 because 1s and 3p3 plus 1 4 sp3. Whenever sp3 hybridization, what is the geometry? Geometry is tetrahedral, but what is the shape? Shape is pyramidal. Clear ma? So what is the geometry here? Geometry is clear ma? Geometry is tetrahedral. But what is the shape here? Shape of the molecule is, 3 bond pairs and 1 lone pair. The shape is pyramidal. Pyramidal shape. Clear ma? What is the pyramidal shape here? Xenon and a double bond O, and here there will be a double bond O, and here there will be a lone pair of electron. This is what it is here, pyramidal shape. Clear? And next one here, XeO4. XeO4 means, how many bonds xenon will form with the oxygen. Each oxygen forms 2 bonds with the xenon. Clear? How many bonds? How many oxygens are there? 4 means total how many bonds? 8 bonds. 8 bond means all these electrons should be involved in the reaction. So that's why how many bond pairs will be there here? Means another double bond will come here. How many? 4 sigma bonds and 4 pi bonds. Pi bonds never considered in the hybridization. So 4 bond pairs. Is there any lone pair here? 0 lone pair. So total one is 4. What is the hybridization? sp3 hybridization. 4 bond pairs, 0 lone pairs. What is the shape here? Tetrahedral shape. Tetrahedral shape. So what is this one? And xenon, and this is double bond, and this is double bond, and here this is the XeO4. Clear? So this is about what it is here. Texture of xenon fluorides and xenon oxides. So next one is structure of XeOF4. Clear? Now you see xenon forming how many bonds here? Xenon is forming 6 bonds because with 4 fluorine atoms 4 bonds. And with the oxygen 2 bonds. Totally how many bonds xenon is forming here? 6 bonds forming. When xenon is forming 6 bonds means it should have how many unpaired electrons? 6 unpaired electrons. When it is having 6 unpaired electrons, it will have 1 lone pair. Clear? So that's why totally here there will be a 5 bond pairs. Simple one. Just to see. This is fluorine, 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 and fluorine, and oxygen is double bond. So total how many bonds it is forming? 6 bonds. When it is forming 6 bonds, it will total 8 electrons. 2 electrons have 2 electrons means as a 1 lone pair. Clear? And but how many bond pairs are there? Sigma bonds only we will consider as a bond pairs. 5 bond pairs and 1 lone pair. Clear? So what is the hybridization here? 5 plus 1 6 means sp3d. sp3d2. What is the hybridization one? sp3d2. And sp3d2, what is the shape of the molecule? And square pyramidal. What is the shape of the molecule? Square pyramidal. This is the shape of the molecule. Square pyramidal means what it is? Here xenon in the center. It is a square. So here this is square. Fluorine, 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 and here fluorine. So sorry, one is oxygen. Total 4 fluorine atoms, and another one is what it is here? Oxygen. Clear? This is about XeO4. In the same way, whatever it may be, and XeO4 and XeOF2 or XeOF4, whatever it may they give, you can write the, in the first year chemical bonding we have studied already. If 5 bond pairs and 1 lone pair, what is the shape? And if it is 5 bond pairs, 0 lone pairs, what is the shape? And that you have studied already in the first year. Based on that, you have to write the shape and the structures of the molecule. Clear? So another one simple I will write here. XeOF4 we have discussed. XeOF2, XeO2 and F2. So if you take here XeO2 and F2, so here you see xenon forming how many bonds? And xenon forming here 2 fluorine and 2 oxygens are there here. So how many bonds? 1, 2, 3, 4, 5, 6. Totally 6 bonds. But 6 bonds are forming. But how many bond pairs are there? 4 bond pairs. There are 4 bond pairs. And how many lone pairs? When it is forming 6 bonds, 1 lone pair will be there. There will be 1 lone pair. So 4 plus 1, 5. What is the hybridization? sp3d. When 4 bond pairs and 1 lone pair, what is the shape of the molecule here? And trigonal bipyramidal. What is the shape here? Trigonal bipyramidal. bipyramidal shape. Clear? Means if I take here trigonal, clear? So this is triangle, and if I take this is the triangle, clear? If I take here xenon, clear here? So xenon, and there will be a two oxygens here. There will be a two oxygens, and there will be a one lone pair. There will be a one lone pair here oxygens, and here this is what fluorine and fluorine. So this is about a trigonal pyramid, and this is about the what it is here structures of what it is here Xenon compounds. So here I have written all together hybridization and shape. This is important for the examination competitive. And here XeF2 sp3d linear and XeF4 sp3d2 square planar, XeF6 and distorted octahedral, XeO3 and XeO4 sp3 hybridization. One is pyramidal shape and another one is tetrahedral shape. XeO4 and sp3d2 square pyramidal, and XeOF2 hybridization is sp3d trigonal bipyramidal, and last one is XeOF2 sp3d T shape. Clear? So here last concept is uses of noble gases. Clear? So the first one here, sometimes they are asking one more question from this area. You have to be careful. And first one is helium. Helium is non-flammable, light gas. Clear? So it is non-flammable. Suppose if you take hydrogen, hydrogen is inflammable. It catches fire easily, but it is a non-inflammable gas. Clear? Light gas, lighter than air. Clear? And it is used in filling balloons, and helium balloons. And you might have seen that one balloons, and mainly it filled with the hydrogen and or helium. And hydrogen means it is inflammable hydrogen, so that's why instead of hydrogen nowadays what are using here helium for filling the balloons. And it is also used in the gas cooled nuclear reactors. Nuclear reactor also to cool, and and it is having very low, helium is having lowest boiling point, so that's why, and for the cooling purpose in the nuclear reactor it will be used. And the liquid helium is used as a cryogenic agent. Cryogenic agent means what is not? Means to perform the reactions at very low temperatures, and we have to use the what it is here liquid helium. And next one, it is used to produce and it is superconducting magnets and produce the sustained powerful superconducting magnets. And so that's why in the NMR, nuclear magnetic resonance spectroscopy, MRI spectroscopy, and here and helium is used. And it is used as a diluent for oxygen. Previous we have already Henry's law applications we have discussed in that one. And and C divers, they will use the oxygen cylinder which is diluted with the helium. Because and so that's why nitrogen, if it is more amount of the oxygen and nitrogen is present, then when we are going inside the water, then pressure increases and automatically nitrogen will soluble in our blood. When we are coming to the top of the surface of the water, and then nitrogen will come out through our blood cells, and we will get the pains of those diseases we will cause as a pain. So that's why, and it is diluted with the which one? Helium. So these are main important points of helium. Neon, and it is used in the discharge tubes and fluorescence tubes. Clear? That is, it is filled with the what is called neon. Neon bulbs are used in botanical gardens and also the greenhouses. In greenhouses and botanical garden, and the helium filled bulbs are used. Clear? And argon, it is mainly provide the inert atmosphere at a high temperature. It is mainly used to provide the inert atmosphere. Suppose you wanted to do the reaction at very high temperature, but we need inert atmosphere at that time, and oxygen means argon is filled to create the inert atmosphere. And krypton and xenon don't have much uses, but they are also used in the filled lamps, gas filled lamps they will use instead of what argon also filled, but it is also used in the filling electrical bulbs, and these are better than the argon for the gas filling lamps. And the important last one, radon is radioactive, so that's why it is used in the cancer treatment. And this is about the uses of 18th group elements. Now we have completed total P block elements. Clear? 15th group, 16th group, 17th and 18th group, totally it is completed, and next we will go for the competitive. So we are also previous chapters also we have discussed the competitive, and level 1 you have to practice perfectly. Yeah, and in this chapter also we have level 1 and level 2, and you also just go through the level 1 and already completed competitive part chapters. You have to go through the level 1 and very compulsory level 1 you have to practice, and the level 2 also you have to practice perfectly. So another important point here, we have provided PU material also. Most of the students they have collected, and in that one each chapter contains level 1 and level 2. Clear? All level 1 questions you have to practice. So practice means simply don't read and you have to write. Next time when we come to your college you have to submit. We will give you date, message we will send. On that day you have to submit the and notebook, like so notebooks you have to submit, we will send one message. So during that time you have to write and practice in one separate notebook, and that notebook must be submitted here in the college. Only level 1, and next we will give you the level 2.